Hello YouTube friends, in today's video I'm going to be showing you how to get the surface area of a right circular cone. Now the key to getting the formula of the surface area of a right circular cone is in knowing that its base is going to have the circumference 2 pi r, that it's going to have the area pi r squared, and that the top of this cone is going to have the area half times big R squared multiplied by theta. With this key, we can say that the surface area of the right circular cone is going to have the equation the area of its base plus the area of its top. And we've already established that the area of its base is pi r squared and that the area of its top is half multiplied by big R squared multiplied by theta. So at the moment, the surface area of a right circular cone is going to have this equation over here. And what we're going to do in this video is simplify this equation so that we get something more beautiful. Okay, so how can this equation over here be simplified? Well, it can be simplified by acknowledging that the top of this cone, the length of its arc, is going to have the equation big R times theta. Okay? Now, because the top of this cone is going to be connected to its base, which has a circumference 2 pi r, we can say that L, which is big R times theta, that's the length of the arc of the top of the cone, is equivalent to the circumference of the base of the cone, okay, which is 2 pi r. These two figures over here are going to be connected. Now, because this is the case, we can say that 2 pi r is equal to big R times theta. And with this equation over here, we get theta is equal to 2 pi r over big R. If we plug this value of theta, okay, back into this equation up here, alright, like I've done over here, what we end up getting is pi r squared plus pi multiplied by r multiplied by big R for the surface area of this right circular cone. Okay, this is what we end up getting. And from here, we're going to simplify further to get an even more beautiful equation. So to get this more beautiful equation, what we're going to do is connect the base of this cone to its top. We are going to assemble the piece, okay? And then we are going to look at this piece from this perspective right over here. And as you can see, with this perspective, we get a height of the cone small h, okay? And we've also got a right angled triangle. We are going to use this right angled triangle to get an even more simple equation for the surface area of a right circular cone. I'm going to give you a little spoiler here. The surface area of a right circular cone is going to have this equation over here. This is the formula for it. And it's made up of the small r's plus h, which is the height of the cone, okay? What we want is a formula in terms of small r and h, okay? And to get this final formula, which I've just shown, we need to use Pythagoras' theorem to get rid of the big R, okay? We want to get rid of this big R over here, so we get a formula in terms of small r and also the height of the cone. Okay, according to Pythagoras' theorem, small r squared plus h squared is going to be equal to big R squared, okay? And if we transform this equation over here, what we get is big R is equal to the square root of r squared plus h squared, alright? And if we plug this value right over here into this equation over here, alright, what we end up with is this, okay? Pi r squared plus pi multiplied by r multiplied by big R. And we just simplify from here to get our final formula, okay? We get this value of r over here, which is the square root of r squared plus h squared, and we plug it into this equation over here, and we end up getting the final formula. So I'm just going to show you how to do this so that we can complete this proof. Okay, so we're getting the value of big R, which is this over here. We're plugging the value into this equation over here, so we end up with this, and then we simplify using brackets, so we end up with pi r multiplied by r plus the square root of h squared plus r squared. And what we end up with is this beautiful formula over here for the surface area of a right circular cone. And you can actually find this formula on Google. If you search for the surface area of a right circular cone, you're going to get this value over here in terms of R and H. If you've enjoyed this video, please support me by following me on Instagram. That is mathematics.proofs. Here you can find plenty of GCSE and A-level mathematics proofs. If you haven't subscribed to my YouTube channel, do so. Anyway, I'll see you around.